Wow, this is quite a big stage, isn't it? And not that I'm scared, but I'm quite scared. Good afternoon, ladies and gentlemen. Today I'm going to talk about JavaScript integrity, which sounds like a particularly exciting thing. And also, I feel totally lost without having something to hide behind like a lectern. So today we're going to talk about three things. We're going to talk about the JavaScript attack surface, the new requirements in PCI DSS version 4, and we're going to talk about how we defeat e-com scripting attacks. By way of introduction, my name is John Elliot. I'm a security advisor with Jscrambler. And before that, I've done a lot of things in PCI for the past few years. And I'm going to start off with really a bit of an educational session, which is this, which is, do we all know what JavaScript is? Not everyone's nodding. You're nodding. Thank you, sir. So JavaScript's a programming language. It executes as an interpreted programming language. It executes in the consumer browser. It's really how the web works. It's what gives us interactivity. It's what's changed the web from being a static thing to a dynamic application environment. And Gmail was probably the first time we saw that happening. And so let's run back and remind ourselves about how the internet works. So you go to the merchant's website and you say to the merchant's website, I want a web page. And it says, OK, have some stuff to make a web page. Have some images, have some text, have some cascading style sheets, and have a bit of JavaScript. And then typically what happens now is you get a bit of a web page. But then it's like, well, actually, can I have some more JavaScript? So you get some more JavaScript from the merchant's website. And then maybe, well, hey, I want some more from another, like a library server on the merchant's website. And it's like, here you go. So now I've got lots of JavaScript running in my it's like a Hello Kitty web. It's like a nice cat website. And then we said, well, actually, you need to go off and get some JavaScript from some third parties, from maybe from something like Hotjar or Clarity, something for user experience or for A and B testing. So we tend to now load JavaScript from many different third parties that's resident in the consumer browser. And then maybe we come across an advertising tag manager like Google Tag Manager or Insight. And so like, OK, I want some JavaScript from the tag manager. And the tag manager is really a container for more JavaScript. I describe it as a way of the marketing department putting JavaScript from people you've never met on your website. And so you get lots of JavaScript, again, coming back from all these advertising and tracking and profiling things. So at the end of the day, we end up with this pretty heavy, big website. But now this is going to be an e-commerce site. We're going to buy that picture of a cute kitten, right? And so now we need to maybe go and get some JavaScript from our acquirer or payment service provider or e-commerce gateway, whatever we call it. So we do that, and we've now got a payment form. So we type in our payment card information, and we click the Pay Now button, and the payment information goes through to the payment processor, and the transactions happen. Everyone happy with that as a business, of a model of how the internet works now? Because if we are, now let's look at how you attack that. And we attack that by the criminal having some criminal JavaScript. Look, it's in scary red, so we know that's the criminal JavaScript. And the criminal JavaScript somehow gets into our web page. And so we're going to do the checkout thing again. So we go to the payment service provider, we get our payment form. But now, because the criminal JavaScript is running in the same domain object model as the website, as everything else, it has access to any data that's entered into the payment form. And so as we type in our payment card information, the criminal JavaScript could hook into those fields and read the contents of those fields. So we press the Pay Now button. That's great. The payment goes through to the payment service provider or acquirer as normal. But it also goes off to the criminal web server. And this is a brilliant attack because why? Number one, the criminal doesn't need persistence in the merchant environment to come back and steal the cardholder data, right? And secondly, the transaction has happened as normal. The consumer's not noticed the transaction fail. The merchant's not noticed the transaction fail. The payment service provider's not noticed the transaction fail. And so we have a silent attack that's really hard for any human to detect. Everyone clear on that? OK, so now let's think about the attack surface. How does that nasty red criminal JavaScript get into the consumer web browser? And the answer is, well, the criminal needs to attack anywhere that's loading JavaScript. Now, if you're running ahead, you can think, gosh, I've got a laser pointer. It almost shows up. But gosh, there's a lot of places where JavaScript is being loaded in that web page, isn't there? It could be coming from the merchant's website. And that is how British Airways were attacked with a Magecart ecom skimming attack a few years ago. A secondary web server at BA was attacked, and the criminal added 11 lines of JavaScript to an existing library that was used. It could come from any one of those third parties. Right? And again, that's how Ticketmaster was breached. The criminal deliberately attacked the chat, the online chat, like you're making a transaction. Like Clippy, I see you're making a transaction. Do you need any help with that? The criminal deliberately attacked the JavaScript at a third-party provider. That was loaded into Ticketmaster's checkout page, and they compromised lots of payment card data. It could even be into the tag manager. And so the criminal JavaScript is added to either the tag manager itself or any one of hundreds of tags. Tag is marketing speak for JavaScript from people you've never met before. Right? Any one of those could have criminal JavaScript added to it. And so we've actually got quite a big attack surface there. And that's how the Avaline breach happened. And that was actually very clever, because it wasn't like Ticketmaster, where they knew exactly which site they were attacking. So they wrote generic skimming that said, OK, if it's Square, do this. If it's Stripe, do this. If it's FIS, do this. Right? So it was like a whole set of nested ifs, worked out who the payment processor was, and stole the data. So the question you're now asking yourself is, well, John, how do we stop those attacks? Yeah? And the answer has to be this, is we need to make sure that any JavaScript that's running in the consumer browser, whoever it comes from, we need to check it when it's added to the page and when or if it changes. Right? That's what we need to do. So we need to say, well, do we know what the script does? Do we know what the functionality of the script is? Do we know if that script needs to be on the payment page? And this is still, I'm thinking about PCI DSS 3.2.1, the current version. Is where it comes from fully compliant with PCI DSS? Because I think we've just all agreed that that script can affect the security of cardholder data, and I think that makes it in scope. Right? And then the second thing is, when a script changes, was that change authorized? Was it a change we expected? Was it going from jQuery 1.6 to jQuery 1.7? Does it have any new functionality in it? Is it reading the form fields? And is that change a malicious change or a benign change? So we need to monitor changes. And unfortunately, the only place you can do that is in the consumer browser, because it's only the consumer browser where the page is assembled and all the JavaScript exists. When I started off, my first website, everything came from my own web servers. So I used file integrity monitoring in accordance with PCI DSS requirement, 10 point something? 10 point something, isn't it? Thank you, 11 point something. So I had like FIM on there, so that was OK. But now, FIM's no good if it's just on your web server, because the JavaScript's going from all over the internet. So the very clever people at the PCI SSC added some new requirements to PCI DSS version 4 to prevent these attacks. There's two requirements. The first one, if you follow in this cybersecurity framework, the first one is in the identify and protect. And that is to say that the scripts on a payment page need to be managed. And there's really four things. That you need to have an inventory of them. They need to be necessary for the functionality of the payment page. You need to be able to assure the integrity of them, and you need to work out, and they need to be approved by, and the guidance says management. So that's 6.4.3. You can read it yourself. And then 11.6.1 is saying, OK, now the script is authorized and it's supposed to be on the payment page. You need to monitor whether it changes or not. So again, you can go get a copy of the standard from the council and read it. So basically, I'm simplifying things because we only have 20 minutes here. Firstly, you need to manage all new scripts that are added to the page. Then you need to monitor for changes. So effectively, you're asking for continuous assurance that the JavaScript running in the consumer browser is not going to try and steal your cardholder data. Everyone cool with that? Right? And they're two great new requirements. I think they're best two new requirements in PCI DSS version 4. So what does Jscrambler do? Jscrambler very simply adds some more JavaScript to the web page. It loads first, and effectively, it's an agent that loads into every session. And that agent then intercepts all other JavaScript that's making calls in the browser. So effectively, it's the first loaded JavaScript, the agent loads, and then a whole set of rules load that say, well, what can scripts do? Can anything else touch the payment card data? I'm being very simplistic in 20 minutes, okay? Which means that because it's monitoring everything that's happening in the browser, the first thing is it can give you a real-time inventory of all JavaScript in the browser. The second thing is, if you put rules in there that says no other JavaScript other than the one that comes from the payment processor can access these 6 form fields of card number, CVV, etc., it will enforce that rule and stop anything else doing it. So it says, what's the script allowed to do, what its allowed behaviors, what data can it access. But more importantly, if a script starts showing malicious behavior, then it can block that script accessing that cardholder data in real time and then send you an alert. So it goes above and beyond those 2 best new requirements in PCI DSS. And then it puts reporting and alerting. Now, no one's done a demo yet, have they? And you might notice the reason no one's done a demo is, can you see where my demo computer is? Okay, so I recorded a video. I've never done a demo where I've recorded a video before, so this may go really badly wrongly. And I appreciate that my really badly wrongly is is really effectively between you and beer. So we're going to go shopping. We're going to go to the Jscrambler shoe shop, and we're going to buy some shoes. So I'm going to click on the Shop Now button, and which one should we buy? The red ones? The red ones look pretty good, don't they? And the answer is yes, because this is a recording, remember. So I can't, if you said, no, get the black ones, I can't do that. It's a recording. So I'm going to buy the red sneakers. I'm going to add them to my basket or cart. Do you call it cart in America? Yeah, my shopping cart. I'm going to hit the checkout button. There it is. I'm going to type in my details. I'm going to type my name in, which is, what's my name today? Eric Blair. I'm going to type in my telephone number. I'm going to type in my location. And hopefully in a second, I'm going to go to the payment page. You see that's trouble with a recording is it doesn't go at the same speed that I go. Right, I'm going to type my card holder data in. So I type my card in, I'm going to type my card number. I'm going to use my Visa card number. We all know the 424242 because it passes the LUN check. It's probably not a real card number, so I don't need to be PCI compliant on these monitors. And I'm going to hit the Make a Payment button, and I'm going to make a payment. And I've made a payment. So now I'm going to go back to the Jscrambler reporting console because the agent's been running all the time in the background and see what's happened. And this is deliberate. There is some skimming code running on that shopping website. And we see that there's a request in there that's actually taken the cardholder data and exfiltrated it. I'm going to show you, first of all, the inventory. So come on, demo, let's look at the inventory. Talk amongst yourselves for 2 seconds. Okay, so here's the inventory of everything that's on the website, and you'll see that reporting is the agent's reporting every single JavaScript library that's loaded on the website in real time and how many sessions it has appeared on. So this is giving you complete insight to the JavaScript that's running in all the user sessions. It shows you if it's a first party or a third party, and how many sessions it's been running. If I look at Microsoft Clarity, let's stop and look at Microsoft Clarity, and we can see that that's in 144,000 sessions. These are the 2 bits of JavaScript. We've got some idea of what it's doing, and in a second, it's going to show us a nice little graph. This is very much dummy data, so it's not actually perfect data, but it'll show you a graph of how many sessions are in, whether it's being loaded by more. So we can look at that, and if we carry on looking at our thing, we see this one called Express Ads. And if I click on that, that's tracker.js. It's coming from a Russian domain. It's recently got added to the site, and it's in the checkout section. So that's starting to worry me somewhat. So I'm now going to look at the details of the attack. And so I can look at our sensitive information browser. And this is really quite cool. I'd love to be able to actually really demo this and show you the fact that it will show you any JavaScript that has touched any of the sensitive data we've targeted. So we've listed some sensitive data there of card numbers and everything. If I were to click on that, it would show me which JavaScript's done it. Express Ads is my worry, so I'm going to go and look at Express Ads. I click on the filter there, and it shows me very clearly that there's been some form data access and network transfer from that Express Ads piece of JavaScript. Let's look at the form data access, and gosh, what a surprise. That was the one that looked at the cardholder data, and the network exfiltration also exfiltrated the cardholder data. So that's what we want to be able to block, isn't it? Yes, John? Right. So let's go and reconfigure our rules. So we're going to reconfigure our rules, and we're going to turn on the rule that says block click poisoning in the payment page. So we're going to turn that on. Then we're going to regenerate the agent so that, yes, please, so that now, next time that anything loads it, let's go shopping again, with the new agent with that turned on, and see if it blocks the attack. So I'm going to go shopping again. I'm just going to the checkout page, because you didn't need to see me buy some different sneakers. Type in my phone number. Come on, quickly, more quickly. I've only got 4 minutes left. The clock's gone red here. The demo's not going quickly enough. And type in my name, payment card number. Let's put a dummy number in. Put in this. I know that's not a card number. Okay, it doesn't begin the right thing, so don't tell me that. Type in the CVV, and I mean CVV2, obviously, because we know that. Type in the expiration date. Press the make a payment thing, and again, as far as the consumer's concerned, it's the same thing. We get the confirmation screen. Like the timing on that, we got the confirmation screen. Right, let's go back to the Jscrambler portal and see what we see. And hopefully what we'll see is that there was an attack, there was some tampering and code poisoning, and we blocked the attack. So this time the attack was not successful. And if you want a real demo of this, come to our booth and we can do that. But we can show you which script was blocked, what it was trying to do at the time. In fact, we can even delve in and go straight into showing the JavaScript itself. So that product is called Web Page Integrity. There's an agent that's added to every session. It does real-time inventory. It's got rules in it. We can look at the behavior of scripts and tell you what they're doing. And if a script changes or a script exhibits malicious behavior, and we've defined where our payment fields are, we can block any access to those payment fields. And I think that's a pretty neat thing to be able to do. So that fully meets the requirements of PCI DSS version 4 of 6.4.3 and 11.6.1. We have another product called Cold Integrity, which does polymorphic obfuscation. That's really suited to payment service providers, where you're delivering your JavaScript to all your merchants, and you need to guarantee in the integrity that you're delivering the JavaScript to your merchants. And this is actually really clever. I've got 2 minutes, right. This is really clever, because in payment terminals, we spent a lot of time doing tamper detection and tamper alerting, and tamper failure. If it's been tampered, we stop the transaction happening. Our Code Integrity product, what it does is it takes your JavaScript, it obfuscates, it uses some pretty clever obfuscation, and then it puts dead functions in there. And then, when because if you're trying to reverse engineer some obfuscated JavaScript, one of the things you do is you call all the functions to see what they do, because you're trying to work out how it works. If you call one of these dead functions, it will A, send an alert back to your seam, or send you an email if you haven't got a seam, but B, it will either drop the session cookies, kill the thing, and so anyone who's trying to reverse engineer it can't successfully reverse engineer it. And it's polymorphic, because every time you call it, it gives you a different obfuscation. So if someone's halfway through reverse engineering it, they have to start from scratch again. So that's what Jscrambler does. Most of the Web Page Integrity product is really designed for merchants, the code stuff more for payment service providers. But we'd love to come and give you a proper demo that's not recorded and doesn't have little pauses in it. So what can we offer you? We can offer you a couple of white papers for merchants and for service providers. We can do a free inventory of your current ecom website. So if you're worried about how much JavaScript you've got on there, just come and ask us. We'll actually we'll make that inventory for you and send it to you, so you can see what JavaScript's on there. I'm going to finish by saying, I've been responsible for payment security at a very big European airline. And I wanted to stop JavaScript being added to the payment page by actually being added to my website by the marketing department. All right? And I never won that battle, because, and I'm not going to win that battle. But what I did want to do is I wanted the transparency of being able to see when new JavaScript was added to the site, to work out what it was doing, should it be there, and then go and talk to whoever had added it and say, are we okay with this? That's good, that's bad. And so this gives you, from an IT perspective, it gives you observability of what's happening in the consumer browser and puts you back in control of managing it. And because we can have rules in there that block stuff, it allows you to slightly sleep at night. That means actually, if you got some malicious JavaScript in there, it wouldn't initially start stealing cardholder data. I hope that's been really useful. I know now we're 10 seconds away from going back to the vendor showcase and networking and maybe with a beer. Thank you very much for your time.